Add, subtract, and multiply polynomials. Evaluate. So let's go over a lot of terms before we begin. So the word term actually means the product of numbers and or variables. So examples would be like xy or 5ab or just -6. Those are all different terms. Each one would be one. Now, what's monomial is just one term, right? So just like one of these, right? It could just be x or y, like xy would be one. What's a binomial? Well, that's just two terms. So it could be like xy plus x squared. That's what that would be. It's like two different terms being added together or one being subtracted from the other. Trinomial is three terms. Right, so we could have y squared plus xy plus x squared. A polynomial is just many terms. And now the word evaluate. It just means we're going to replace the variables with values. So let's look at some equations that we're actually going to evaluate. So these are physics equations. So the first one is actually going to be, so the difference in x, so kind of like the distance traveled, which is, right, so the change in x, which would be the distance. VO is going to be our initial velocity. So what does it start out with? Which is usually in terms of meters per second. Now we have t for time, which you'll see here and here. Then we have a. Well, a is acceleration, which is in meters per second squared. And then time is usually in seconds. Now, how do we find acceleration? Well, acceleration actually can be found by taking the final velocity and subtracting it by the initial velocity. And we're going to divide that by time. So that would be acceleration per. Now let's go over some examples. Example 1. A cyclist is going 7 meters per second along a fairly straight road. An elderly person gets into their path. This causes the cyclist to use their brakes. They come to a stop in 5 seconds. Determine the distance between the cyclist and the elderly person when they're first starting to apply the brakes. So let's start with, what are we trying to find? Well, we're trying to find the distance between the cyclist and the elderly person when they're first starting to apply the brakes. Right, so you have, we'll say, a bike, and then you have a person. Right, so we're trying to find this distance right here. So this is the change in x. So that's what we're trying to find. Sometimes a little diagram kind of helps to explain things. And then what do we know? Well, we know that the cyclist is starting out at 7 meters per second. So we say our VO or our VI, depending on which equation we're looking at, because the acceleration one has VI, which is going to be 7 meters per second. The other thing we know is that it takes 5 seconds to come to a stop. So our t is 5 seconds. Then looking at our equation, because this is the only equation that has the change in x, so that's the one we're going to be using. So if we know t, we know our VO, we're trying to find the change in x. The only thing we don't know is our a. So we need to solve for a. So we know a is v final minus vi over t. So we actually have to solve for a in order to be able to plug it in. So our v final, this is kind of like not completely told to us, as in we just have to be ordered to filter it out, is going to be 0 meters per second, right? Because they're no longer moving when they get to that person, because they came to a full stop. So that is going to be 0 minus vi, so that's 7, over our time, which is going to be 5 seconds. So what do we get? Well, we get negative 7 over 5 meters per second squared. So that's our a. Now let's go ahead and solve, because we found everything we need except for our change in x. So let's plug everything in. So the change in x, which is equal to 7 meters per second, and then we have 5 seconds, plus 1/2, and then our a value, so we'll put that, right, all our values that we plug in, we are going to put in parentheses, and then we have 5 seconds squared. Now let's go ahead and solve. So let's first deal with our exponent, and then we'll deal with our multiplication, and then we'll add finally, dealing with our order of operations. So we get the change in x. So this is 25 seconds squared, because 5 times 5 is 25. And we just have seconds squared. Now let's go ahead and deal with our units real quick. This is kind of cool. So seconds can cross out because when we multiply, seconds over seconds is just 1. Then we have, this is seconds squared, and then this is seconds squared. So this crosses out. So we're left with just meters, which is exactly what we want, because the change in x is going to be in meters. So let's go ahead and now just multiply everything out. 7 times 5 is 35, plus, then we have, this become 1, this is 5, so negative 7 times 5 is negative 35, over 2, which is 17.5. So now let's go ahead and solve. So we have 35 minus 17.5, so then we should just get 17.5. And this is in meters. So that's how long that's the distance from when you started to apply the brakes. In those 5 seconds, he went 17.5 meters.